Good afternoon. Today is Wednesday, November 9th. So today we will finish 5.4 and start 6.1. Uh, this week we have a quiz. Quiz 6 is on Friday. So it covers about chapter 5. Okay, so chapter 5, we talk about 5.1 up to 5.4. So I hope you can do your homework, and then we have a quiz on Friday. If you have any questions, print screen and email to me or come to my office hours. Let me check. Do you have any questions on the homework? No? Okay. Right. Okay. So, and then next week, Wednesday, we will have another quiz. You can see we're very close to the end of this semester, right? So our exam is on the Monday before Thanksgiving. And then, right. Okay, so please try your best to. Wednesday?
Yeah.
No, a Thanksgiving break. Yeah, so our school, holiday from Wednesday to Friday, right? So you might have class on the Tuesday. So we have class on Monday and Tuesday, and then no class on Wednesday. Yeah. Okay. So go back to the last time we talked about those common angle. 45 degree, you can draw a triangle with the sides 1, 1, and then the hypotenuse. The hypotenuse is square root of 2. Do you remember that? And also this graph, right? You have the angle value, the 60 degree and 30 degree. So therefore, this side is 1, and then the hypotenuse is 2. So that's why the remaining side by the Pythagorean theorem is square root of 3. So this can show us the table. So this is the 6 trig functions of the common angle, 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. So make sure you memorize all of these values, because in the exam, I will ask you to find exact values. So if you use your calculator and get decimals, you won't get full points. Okay, so this is the practice exam 3, and you can see a lot of the problem. Find exact values of the following. Do not use a calculator. Okay, so make sure you can memorize the values on the table. And I taught you how to memorize. You look at the sign first, right? And you remember the formula is square root of n over 2. And you let n goes from 0, 1, 2, 3, 4. That will take care of all the sine values. And then the values of cosine, same number but reverse order. Right, everybody? And then tangent is sine over cosine. Right? Use your sine value divided by your cosine to get the tangent. And then cotangent, same number as tangent, but reverse order. And secant is 1 over cosine. So 1 over the cosine value, get the secant. Cosecant, same numbers as the secant, but reverse the order. Yes, everybody? So make sure you can remember these values. It's very important. Okay, so let's keep going. Co-functions, identities. Okay, so when we have complementary angles, so this co-function, the co is actually comes from the complementary angles. Okay, complementary. Okay, so remember, two angles are complementary if the sum of them equals to 90 degrees. Do you remember that? Supplementary is when the sum equals to 180 degrees. Okay? So cofunction, complementary angles. Sine A equals cosine 90 degrees minus A. Okay, so you can think of sine and cosine. So the cosine is the cofunction of sine, right? So sine A is cosine 90 degrees minus A. Cosine A is sine 90 degrees minus A. Why is that? Well, look at this. Let's say this is A, and let's say this is B. Sine of A, opposite over hypotenuse. But look at the angle B. This side is actually the adjacent of B, right? So adjacent over hypotenuse is the cosine. Yeah? So you draw the triangle and then you can figure it out. And then secant and cosecant. So secant A is cosecant 90 degrees minus A. Cosecant A is secant 90 degrees minus A. What's secant? Let's say secant of A. Secant is 1 over cosine. Cosine is adjacent over hypotenuse, right? So secant is hypotenuse over adjacent. But look at the B. Look at the B. Then we have this adjacent to A is the same as opposite of B. So opposite over hypotenuse, hypotenuse over opposite is cosecant. Right, everybody? Similar, we got tangent A is cotangent 90 degrees minus A. Yeah? So look at A. Tangent, opposite over adjacent. But if we look at B, well, that's the opposite over adjacent. Then this is, according to B, this is adjacent of B over the opposite of B. So that's why that's the cotangent. Right, everybody? Mm-hmm. Okay, so the cofunctions, we got these identities. Now let's look at this example. If sine t equals 5 over 12, what's cosine pi minus t? Pi over 2 minus t. By the way, what's pi over 2 in terms of degree? 90, right? 45 degrees is pi over 4. 60 degrees is pi over 3. 30 degrees is pi over 6. Right. Oh, you see? This is the same as cosine 90 degrees minus t. And by the cofunction identities, that's sine of t, which is 5 over 12. Right, everybody? Mm-hmm. Good. Okay, so save. Keep going. Find the unknown side of the triangle. Okay, so here we have the right angle triangle. We know 30 degrees, and we know this side is 7. Find the unknown side of the triangle. So we want to find A and C. Yes, everybody? So this is our angle. If we want to find A is adjacent of this angle, right? The known value is 7. What's 7? Opposite, right? So you want to relate opposite and adjacent. What trig function do you use? Tangent, right, everybody? So, oops. Okay, tangents. Yes. So we have opposite. Okay, so tangent 30 degrees is opposite over adjacent. Opposite is 7. Adjacent is 8. Yes, everybody? We want to solve for A. So we both sides multiply by A. right? Both sides multiply by a. And then what do we do? Both sides divided by tangent 30 degrees. Right, everybody? We want to find the a. But a is in the denominator. Therefore, both sides multiply by a. So this is a times tangent. This is a cancel. We get 7. And then we want to solve for a. So get rid of the tangent. How do we get rid of that? Divided by it. Yeah, everybody? So a is 7 over tangent 30 degrees. Okay, what's tangent 30 degrees? What's tangent 30 degrees? Yeah, 1 over radical 3. Awesome. Do you know that when we divide a number, it's the same as multiply by its reciprocal? So we divided by 1 over radical 3 is the same as we multiply radical 3. Yeah, so 7 times radical 3. Okay? So this is the answer. All right. And this is just A, right? We still need to find C. Okay, so let's find C. By the way, there are many ways to find C. One way is because you already know A, that's 7 radical 3, and then you can do Pythagorean theorem to find C, right? That's one way. The other way is, oh, I can use this angle. So this is the opposite. We know the opposite. We're looking for the hypotenuse. What trig function relates opposite and hypotenuse? Sine. Right, everybody? So there are more than one way to find the C. Which way do you prefer? The angle, the sine, or the Pythagorean theorem? Which one? Pythagorean theorem? Sine? Sine. Okay, yes. Sine. So we have sine 30 degree is opposite over hypotenuse. Opposite is 7. Hypotenuse is C. Right? We want to find the C. What do? We multiply by C. Equals to 7. And what's C? 7 over sine 30 degree. What's sine 30 degree? 1/2. Oh, do you see? 7 over 1/2 is the same as 7 times 2. Is that okay, everybody? When you divide it by a number, it's the same as multiply by its reciprocal. Oh, what's 7 times 2? 14. Yes. So we find A is 7 square root of 3, and C is 14. Right? Okay. Next. So we know the trig functions of the common angle values. They are 0 degree, 30 degree, 45 degree, and 60 degree, and 90 degree, right? But for other angles, we can use calculators. Okay, so how to evaluate sine, cosine, tangent on a calculator? Make sure your calculator is in the degree mode. So it depends on what mode you're using. Maybe the problem gives you radian, then you use radian. If the problem gives you degree, then you use degree. Okay, everybody? So take out your calculator. Do you know how to change the mode from degree to radian, from radian to degree? Mm-hmm. Good. By the way, on your exams, you use scientific calculator. You have a scientific calculator at home? Okay. Yes. No graphing calculator. Right, that's the calculator policy. Okay, and then enter the trig functions followed by the angle in parentheses. So that's why here, if we have degree, so you use the degree mode, and you put sine 22.89 degree, and then you get this one. And cosine of 589.3 degree, and you get this number. So you enter. Can you see the bottom sine, cosine, and tangent? Okay. How about secant, cosecant, and cotangent? Well, calculator do not have the buttons for these functions. So you have to use the reciprocal identity to evaluate these functions. What is the reciprocal of secant? Cosine. What's the reciprocal of cosecant? Sine. What's the reciprocal of cotangent? Tangent. Yes. So if you want to evaluate secant of 22.89 degree, you put 1 divided by sine of 22.89 degree. Okay, everybody? That's why your calculator only has the sine, cosine, and tangent. It does not have the secant, cosecant, and cotangent because you can use the sine, cosine, and tangent to figure that out. Right, everybody? Okay. Yeah, so to enter the reciprocal calculations correctly, you have to enter 1 and divide it by the correct trig functions. Do not use sine to the -1, cosine to the -1, or tangent to the -1 buttons because they represent the inverse trig functions. So we will talk about the inverse trig functions in chapter 6. Okay? But they mean inverse function. They don't mean 1 over that. So be careful. Now, exercise. How do we compute cosecant? Cosecant is 1 over sine. So 1 over sine 187.48 degree. Plug this in your calculator. What do you get? 682. Thank you. So make sure all of you get the same answer so you know how to use your calculator. Yeah? Yes? We have the same answer? Right? Okay. Okay, and be careful. If you don't have the degree, okay, if I, in a problem, I don't give you a degree. So if I just put 187.48, you don't see a circle there, that means you should use the radian mode. Okay, the radian, you might not always say, you might not always see like pi over 2, or 3 over 5 pi. You not always see the multiple of pi there. Okay, as long as you don't see a little circle, that means we're using radian instead of degree. Okay, everybody? Yes. All right. Now, use trigonometry to solve a right triangles. Example 1. A surveyor is standing 115 feet from the base of the Washington monument. Okay, so let's draw a picture. Have you been to Washington? So we have that one. Okay. Okay, so it's standing 100, and so it's right here, 115 feet from the base of it. And we measure the angle of elevation to the top of the monument is 78.3 degree. How tall is the Washington monument? Is it how you pronounce it? Monument? What? New monument? Oh, thank you. Monument. Okay. Okay, so we want to compute how tall it is. So this is what we're looking for. So now let's see. This is a right angle triangle. Yes. This is the what? Opposite side. Yeah, this is the height, right? It's also the opposite side. And this is the adjacent. Which trig function to relate opposite and adjacent? Tangent. Oh, by the way, you can also use cotangent. But because your calculator has tangent instead of cotangent, it's better to use tangent. Okay, everybody? So tangent of that angle, so tangent 78.3 degree equals what? So tangent is the opposites over adjacent. Opposites over adjacent. What's opposite? H. Adjacent? 115. Ah, can we find H? What do we do? Multiply by 115. So OH equals 115 times the tangent of 78.3 degrees. By the way, sometimes we put a parentheses, sometimes we don't put a parentheses. They mean the same thing. Okay? But in this case, right? Sometimes if there is a confusion, like if you put tangent 78.3 degree times 115. Well, this is very confused. Do you mean we multiply the 115 inside the tangent or outside of the tangent? Okay, so if there is a confusion, then you'd better put parentheses. Okay? Right, everybody? So now plug this in your calculator. What do you get? Yeah, put this in your calculator. What do you get? Oh, 0.314. Thank you. What's the unit? Feet. Very good. Okay. Yes. So this is how to solve a right triangle. You have the angle, and usually you have one side that you know and one side you don't know, and then you think about this is the opposite, adjacent, or hypotenuse to figure out which trig functions you use. Okay, everybody? All right. Example 2. A historic lighthouse is 200 yards from a bike path along the edge of a lake. A walkway to the lighthouse is 400 yards long. Bless you. Find the acute angle between the bike path and the walkway. Okay, so let's draw a picture. We have the lake is right here. So a historic lighthouse is 200 yards from a bike path along the edge of a lake. So here we have the bike path, okay, and then the lighthouse. How do you draw a lighthouse? Like that? Is 200 yards from the bike path. Okay, so this is 200. A walkway to the lighthouse is, bless you, 400. So this is 400 yards long. Find the acute angle between the bike path and the walkway. So this is the walkway. Okay? We want to find the angle, theta. So far, so good, everybody? Yeah, we draw the picture. That's the lake. We have the bike path right here along the edge of the lake. And the lighthouse is 200 yards from the bike path. So the distance here from this bike house to the path is 200 yards. And then the walkway here is 400 yards long. We're looking for the angle between the bike path and the walkway. Okay, so this is the angle. This side is what? 200 is it opposite, adjacent, or hypotenuse? Opposite. How about the walkway? Hypotenuse. Opposite and hypotenuse. What trig functions? Sine. Yes, everybody? Are you familiar with sine? Sine is opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. All of you familiar with that, right? If you don't, please, when after you get home, make sure you can remember all of those. Because every day we learn something new. So the things we learn, make sure you digest them and remember all the trig identities in the table of the common angle values. Okay, so yeah, every day we learn something new. So you're gonna digest the things you ate yesterday, and then you can eat some things today, right? Okay, so we have sine theta is opposite over hypotenuse. Opposite is what? 200. Hypotenuse is 400. Oh, can you simplify them? Yeah. What's 2 over 4? Okay, do you remember what angle? Sine of that angle is 1/2. 30 degrees. Exactly. So theta equals 30 degrees. Okay, everybody? Okay, let me ask you another question. So questions. If you get sine theta is 1/3, how do you find theta? Well, we learned inverse functions, right? Inverse functions. What does inverse function do? Okay, so f inverse x, inverse function will, when we apply the inverse to f of x, we get the x back. Do you agree? And f inverse of x, we also get the x back. Okay, so this is sine. We have inverse sine. Okay, so the inverse sine, we have the inverse sine. So you kind of put sine to the -1 because inverse function you put -1 on top of the f, right? So this is the inverse sine. Okay, sine function. So you have sine theta equals 1/3. Then you apply inverse sine on both sides. Then you get inverse of sine theta equals inverse sine of 1/3. Is that okay, everybody? We apply inverse sine on both sides. Yes? And because of inverse function, inverse sine and sine, they cancel. And you get what? You get the theta back. Yeah, everybody? So you get the theta back. So theta is inverse sine of 1/3. Now, look at your calculator. Do you see the on top of your sine, there is a arc sine? By the way, inverse sine also called arc sine, right? So you enter second and then left button, you get an inverse sine. And then you enter 1/3. What do you get? Bless you. What? 19.47. Is it degree? You have your degree mode? Okay. So if you have degree mode, don't forget to put your degree. Or if you use radian, and then you just put down that number radian. Okay, everybody? So, yeah, in general, you might not have nice number like 1/2. This is the special angle value, okay? Yes. So, other numbers, then you use the inverse sign. And similarly, you have inverse cosine and inverse tangent. Okay, so there are arcsine, arccosine, and arctangent. Okay. Oh, I just made it up. So I'm saying, outside this problem, what if you have 1/3 instead of 1/2? What do you do? Okay, then we can use the arcsine function. Okay, arcsine. Oh, okay. This is another name. Okay, arcsine. So arcsine. They're the same thing. Okay? They both mean the inverse function of the sine. Okay, so we will talk about the inverse rate functions more in chapter 6. Okay. Any questions so far about 5.4? No? Okay, chapter 6. Graphs of sine and cosine functions. Okay. First, definition. A periodic function is a function such that f of x equals f of x plus n times p for every real number x in the domain of f, every integer n, and some positive real number p. The least possible positive value for p is called the period of the function. Well, imagine, look at our unit circle. Do you remember that angle? If we add a multiple of 2 pi, we have the same position, right? So therefore, you can think of like 2 pi is like a period, okay? So like the sine function, the cosine function, this angle, when we add 2 pi or subtract 2 pi to it, we have the same points. So the sine and cosine, we have the same period of 2 pi. Okay, and so this graph, we see the point. So here the angle is 0, and then here the angle is 30 degrees. Here 45 degrees. Here the 60 degrees. So this shows the angle values and also the sine and cosine of the angle values. So they are the points on the unit circle. For example, this point, this is pi over 6. And in the unit circle, xy equals cosine theta, sine theta. So that's why the x coordinate is cosine of that angle. See, cosine pi over 6 is 3 over 2. And sine pi over 6 is 1/2. Okay, everybody? And continue. So let's look at the graph of sine function. So keep that picture in mind. Okay, so sine function. Sine is the y coordinate. Yes, sine theta is the y coordinate. If the angle is 0, sine 0 is 0. Right, everybody? So if theta equal to 0, sine 0 is 0. Okay, if the variable let's say is x instead of theta, if x equals pi over 6, what's sine pi over 6? Look at your common angle value. That is 1/2. Right, everybody? How about sine pi over 4? What's sine pi over 4? What's sine pi over 4? Look at the table. Look at the table. What's the common angle values? Sine pi over 4. Yeah, root 2 over 2. How about sine pi over 3? Sine pi over 3 is root 3 over 2. Yes. Sine pi over 2 is 1. Okay, so these numbers, we learned those before in the table. Okay, keep going. So if we draw the xy plane, we have the first quadrant, second quadrant, third quadrant, and the fourth quadrant. Remember last time we talked about the reference angle? Yeah, reference angle is the angle made by the terminal side of the angle and the horizontal axis. Okay, so for example, if you have the angle 2 pi over 3, this is in the which quadrant? 1, 2, 3, 4. This is in the quadrant 2. Yes, yes. So this is 2 pi over 3 is in quadrant 2. And what is the reference angle? Pi over 3, right? Do you see, everybody? This angle, 2 pi over 3, is right here. The reference angle is the angle made by the terminal side and the horizontal axis. This angle is pi over 3. Okay? And if your angle is not in the first quadrant, then sine of those values will be plus or minus sine of the reference angle. But plus or minus, it depends on the quadrants. Remember, first quadrant, sine is positive. Second quadrant, sine is positive. Because sine is the y. The y coordinate is sine. See, here, above the x-axis, sine is positive. Oh, yeah, sure. So here, sine is positive. Here, sine is positive. Here, sine, third quadrant, sine is negative. Fourth quadrant, sine is negative. So therefore, sine of 2 pi over 3 is positive of sine pi over 3. Is that okay, everybody? Yes. So sine pi over 3 is, yeah, root 3 over 2. Okay. All right. And how about sine of 3 pi over 4? What's the reference angle? Pi over 4. So this is a sine of so sine of 3 pi over 4 equals to sine of pi over 4, which is root 2 over 2. Okay? And sine of 5 pi over 6. What's the reference angle? Pi over 6. So this equals to sine of pi over 6, right? And sine of pi over 6? Yeah, 1/2. And what's sine pi? 0. Very good. Yes, because pi, at this point, you see the y coordinate is 0, so that's why sine is 0. How about, see, this should be 7 pi over 6. Okay, this should be 7 pi over 6. We already did 5 pi over 6. Okay, 7 pi over 6 is in which quadrant? This one, right? So we have right here, this is 7 pi over 6. What's the reference angle? Pi over 6. But because it's in the third quadrant, the sign is negative. So sine of 7 pi over 6 is negative sine of pi over 6. Is that okay, everybody? And that equals negative sine pi over 6 is 1/2. Right, everybody? Or you can think of these guys are in quadrant 2. This is in quadrant 1. And then you have these guys that are in quadrant 3. In quadrant 3, the sign would be all negative. Do you agree? So they are all negative. Okay, 5 pi over 4. What's the reference angle? What's the reference angle of 5 pi over 4? It will be pi over 4. Because, okay, how do you figure out the reference angle again? So if your angle is in the first quadrant, then your reference angle, so reference angle equals to theta. If the angle is in the second quadrant, then the reference angle will be pi minus theta. Yes, everybody? If the angle is in the third quadrant, then the reference angle will be the theta minus pi. Yeah, because your theta is bigger than pi, so to find the reference angle, you use theta minus pi. You get theta. Right, everybody? And in the fourth quadrant, okay, so that's theta. Therefore, the theta prime is, it will be 2 pi minus theta. Okay, everybody? So this is how we find the reference angle. And you know sine theta is either plus or minus of sine of the reference angle. Sine of the reference angles, we know the values. Because your reference angle is between 0 and 90 degrees. For those common angles between 0 and 90 degrees, we know the numbers, right? And therefore, for the other angles, we try to relate it to the reference angle. But plus or minus, it depends on the trig function and it depends on which quadrant the point is located in. Right, everybody? So this plus or minus, it depends on the quadrant and the trig functions. For example, sine, positive, negative. Cosine, positive, negative, positive. Tangent, positive, negative, positive, negative. Right, everybody? Do you remember that? Yeah, so last class we talked about the reference angle and the trig functions. Okay. So 5 pi over 4, what's the reference angle? Pi over 4. So therefore, negative sine pi over 4 is root 2 over 2. How about 4 pi over 3. What's the reference angle? Pi over 3. Yes? Because 4 pi over 3 minus pi is pi over 3. So sine pi over 3 is minus root 3 over 2. Okay, everybody? And how about 3 pi over 2? So that's sine pi over 2, which is, what's sine pi over 2? Yeah, very good. Okay, and then next, quadrant 4. Sine in quadrant 4 is positive or negative? Is negative, yes. Okay, what's the reference angle here? So, see, quadrant 4. The reference angle, 2 pi minus beta. So, what is 2 pi minus pi over 3? It will be pi over 3, right? Because 2 pi is 6 pi over 3 minus 5 pi over 3 is pi over 3. And sine pi over 3 is root 3 over 2. Is that okay, everybody? Okay, and then 7 pi over 4. The reference angle is pi over 4. Pi over 4, root 2 over 2. Is that okay, everybody? 11 pi over 6. What's the reference angle? Pi over 6. And that's 1/2. Okay, very good. So we figure out these numbers. Now we plot them on the graph. Okay? 0, when x is 0, we get 0. So let me use, yes. So 0, 0. Pi over 6. You know, so this is pi. Pi over 6, we divide it into 6 pieces. So this is pi over 6. Is that okay, everybody? So this is pi over 6. 1/2. That's 1. Okay, that is 1. So 1/2 is right here. So we put this point. Okay. And then pi over 4. So pi over 4 is in the middle of 0 and pi over 2. You see? This is pi over 2. So this is pi over 4. And we get root 2 over 2. So that's bigger than 1/2. So let's say this is root 2 over 2. We plot that. Pi over 3. Okay, so are you able to see what I write here? So this is pi over 3, and that's square root of 3 over 2. So square root of 3 is bigger, right? So bigger. And then at pi over 2, we get 1. So pi over 2, we get 1. Okay. So this is what it looks like. And you continue, okay? This is 2 pi over 3, root 3 over 2. Right here. And keep going. 3 pi over 4, here. 5 pi over 6, 1/2, here. So this is 5 pi over 6. And at pi is 0. And then you connect them. So far, so good. So we keep going and plot those points. Here, minus 1/2. So minus 1/2 here. This is 7 pi over 6. Okay, and then next we have root 2 over 2. So right here, and then we have negative root 3 over 2, and At 3 pi over 2, we get -1. Okay? And you keep going. Do you see symmetry? So this point is the same as this point, this point is the same as this point, this point is the same as this point. So therefore, this point is the same as this point. And then here, this point is the same as this point. This point is the same as this point. They kind of have like symmetry on the picture. Do you see that, everybody? Okay, so therefore we connect them. Okay, so this is the graph of sine x for one period. Okay, and you know the when we add multiple of 2 pi or subtract multiple of 2 pi, we get the same angle. So therefore, these, okay, when we extend the x, we get a periodic function. Okay, you have the same shape, and you just shift it. So you have the same shape, and just shift it over here, and then this is a graph of sine x. So far, so good, everybody? Okay, and then you might say, oh, that's a lot of number. It's so hard to put all those numbers on this picture. Well, from now on, when you draw sine, you only plot the point 0, 0, okay? And pi over 2, 1. Pi 0. And 3 pi over 2 minus 1. And 2 pi 0. So you only plot those 5 points. 1, 2, 3, 4, 5. 5 points. And then you just draw them smoothly. Okay? So instead of drawing all these points, you don't need that. You just need 5 points to draw the sine. Okay, everybody? Then you can connect them smoothly. Okay, good. So notes on the graph of the sine function. The period is 2 pi, right? See, the period from here to here is 2 pi. That's one period. The graph is continuous over its entire domain. Continuous means you draw it without lift your pencil from the paper. So what is not continuous? Like if you have something like this is not continuous. Okay, this is not continuous. Continuous like you draw your graph without lifting your pencil from the paper. And the x-intercept. Look at the x-intercept. We have 0, pi, 2 pi. It's actually multiple of pi. So therefore, the x-intercepts occur at n times pi, where n is an integer. Furthermore, the sine function is an arc function. Remember, arc function, we have symmetric with respect to the origin. So symmetric with respect to the origin. Do you still remember even function, the arc function? Arc function, symmetric with respect to the origin. So you have a point, and then you rotate 180 degrees. It's also on the graph. Right, everybody? How about even function? Symmetric with respect to the y-axis. Okay? All right. So this is the sine function. Okay. How about cosine? Cosine, you do the similar things. Let's make things easier. So let's just focus on the easier point. So 0, pi over 2, pi, and 3 pi over 2. Okay, so let's look at those. Cosine 0. So cosine is the x. Right, everybody? So that's why if theta equals to 0. If theta equals to 0, what's the x value? 1. Okay, so cosine 0 is 1. And if the right here. What's the cosine of pi over 2? So when theta equals pi over 2, so at that point, what's the x coordinate? 0. Yes, everybody? That point, the x coordinate is 0. How about when theta is pi? What's the x coordinate? -1. How about when theta is 3 pi over 2? You get what? 0. Okay. At the end, at 2 pi, you get it back to the original point. Therefore, your x value is also 1. Is that okay, everybody? So that's why you plug in, okay, 0 is 1. Pi over 2 is 0. Pi is -1. When x is 3 pi over 2 is 0. When x is 2 pi, we get 1. And then you connect them smoothly. This is the graph of cosine. Is that okay, everybody? And you see the period is also 2 pi. Okay, so if you want to draw more period, you kind of shift these pieces and you get a log complement. Okay, everybody? So yeah, from now on, you just focus on those 5 points. You don't need to draw all those new ones. Just connect those points smoothly, and then you can get the graph of cosine. So the period is 2 pi. The graph is continuous on its entire domain. Oh, by the way, I forgot to mention. Now look at the picture of sine. Your domain is -infinity to infinity. What's your range? Your lowest point is -1, highest point? 1, exactly. So range -1 to 1. Similarly with the cosine, domain is what? -infinity to infinity, right? How about range? Yeah, also -1 to 1. So far, so good, everybody? X-intercepts. X-intercepts occur. See, this is pi over 2. This is 3 pi over 2. So you can think of, well, the x-intercept happens when it's pi over 2 plus n times pi. So this is the same thing, okay? So pi over 2, and then you add multiple of pi. So that's the x-intercept. And the cosine function is an even function. Do you see here? It's symmetric with respect to the y-axis. So that's even function. Symmetric with respect to the y-axis. So this is the graph of cosine. So far, so good, everybody? All right, keep going. Okay, now, if we have transformations, okay, so if we have transformations, how do we draw it? Remember step 1, shift, lateral right? Step 2, we flip over the y-axis. Step 3, we flip over the x-axis and vertical stretch. And step 4, move up or down, right? Okay, now with the transformation. Here, so from now on, we look at 5 points. There's 0, pi over 2, pi, and 3 pi over 2, and the 2 pi. So just look at those 5 points. So let's draw sine 2 times sine x. So first of all, what's sine of x? Okay, and you remember sine 0 is 0, and sine pi over 2, 1, and then 0, -1, and 0. Are you okay with those 5 key points? So when I ask you to graph the sine and cosine function, you just need to show me one graph. You don't need to do the steps of the sequence of the transformations one by one. Is that clear, everybody? Just draw one graph. Okay, you make the table. Okay, always remember if your x, you want to let your x be those 5 points, and you know the sine. And here, what do you do to it? We multiply the y value by 2. You see? So 2 times 0 is 0. 2 times 1 is 2. And then 0, -2, and 0. Okay, everybody? So plot those points. When x is 0, y is 0. When x is pi over 2, y is 2. Do you see the 2 right here? So plot that point. Okay. And then when x is pi, we get 0. When x is 3 pi over 2, we get -2. When x is 2 pi, we also get 0. Okay, connect them smoothly. By the way, when you connect them, don't draw this. Promise me you won't draw line segments. Okay? Connect them smoothly. Okay, right. So this is the graph of 2 sine x. You just need to draw one graph, but please make a table of values. Okay, so this is what I want you to show in the exam. You don't need to draw the steps of the transformations. Okay. But we know, if I ask you what operation I'm doing, well, we only do one operation. This is the vertical stretch by a factor of 2. Right, everybody? So we know this is the vertical stretch by a factor of 2. Okay. How about this one? Similarly, look at those 5 key points. What's the x value? Sine x value. You start with 0, and then 1, then 0, and then -1, and then 0. Okay. What do? You multiply by -1/2. 0 times -1/2 is 0. 1 times -1/2, -1/2. And then 0, and then 1/2, and then 0. Okay, plot it. See, when x is 0, the y is 0. And when x is pi over 2, the y is -1/2. See? -1 is here, so -1/2 is here. So we plot the points here. At pi, we get what? 0. 3 pi over 2? 1/2. 2 pi? 0. Connect them smoothly. Okay, connect them smoothly. So this is the graph. Okay, everybody? What transformation keep reducing? What does the negative do? Yeah, reflects over the x-axis. And how about the 1/2? We have vertical stretch, or you can say compress. It's actually compress. Yes. Okay, compress. Okay. So yeah, in the exam, you might depends on the problem. So if the problem doesn't ask you what translation they're doing, then you don't write that. Yeah, let's continue next class. Have a nice day. And please remember those three identities, the special angle values. And every day we learn something, we learn more and more things. It's very important to adjust. Bye.